You already know how to solve lots of different types of equations. Well, linear equations you've solved before. You've done some rational equations, but not a lot. Quadratic equations you know how to solve. These are radical equations. But really, when you learn how to solve equations, there's two main types that you need to know how to solve. Linear and quadratic. Because every other type of equation that you're going to solve, you're going to turn it into a linear or a quadratic to be able to solve it. And really, if you think about it, the quadratics, you turn those into linear equations to solve when you factor. So that's what we're going to do with this as well. We're going to turn it into either a linear or a quadratic equation. Step one in doing that is to isolate one radical. This one actually only has one radical, so we'll isolate that one. Sometimes you'll have more than one, and you have to decide which one you want to isolate first. And it doesn't really matter which one, but how can I isolate that root y minus 1? Subtract 7 from both sides. So then I get the square root of y minus 1 equals 6. That's the first step. The second step is square both sides of the equation. So I'm going to put on here a squared and on here a squared. And when I square the square root of y minus 1, what do I end up with? Y minus 1. That's why we're squaring. And then 6 squared, 36. What kind of equation is this? Y minus 1 equals 36. Linear. You already know how to solve linear. But look what we did. Isolate one radical, square both sides of the equation. It then says in step 3, repeat steps 1 and 2 until there are no radicals left. Well, we already don't have any radicals left, so we don't have to go back and repeat that. So we can move on to step 4, which is solve the remaining equation, which in this case is linear. Sometimes it'll be quadratic, but that's easy enough to solve. What do I have to do? Add 1. Add 1 to both sides, and I end up with y equals 37. We need to consider restrictions on the variable, and there weren't any restrictions listed, but there are restrictions. Anytime that you're taking the square root of a variable or dividing by a variable, you're going to have restrictions. Because the square root of y minus 1 is only defined for certain values. Anybody know what the restrictions are?
X is greater.
Or y?
Y.
We often say this is y, right? So we're going to do it in terms of y. It's often just y is greater than 0. But it's not always. Because I think this could still be defined possibly for other values that don't fit within that. You choose 0 when it's just the square root of the variable, but this is the square root of the variable minus 1. Y is greater than 1 is the restriction. Yep. That's the restriction. Y is greater than 1. If it's greater than 1, then this thing will be defined, right? If it's smaller than 1, it doesn't. Then we can look at the answer and say, does our answer jive with that restriction? Y is greater than 1, and we got y equals 37. Does that work?
Yes.
Sometimes you'll get answers where it doesn't work. It does here. So we have to consider it, though. If it had said something like y is less than 1, then we go, oh, that doesn't make sense. We can't have that answer. But here we can. So then it says to verify, and how would you verify? Put 37 into y in the original equation, so I'd go square root of 37 minus 1, that's square root of 36, that's 6 plus 7, it equals 13, so good, it's done. Anybody have another way that they could verify? Graphing, yep. You could graph on your calculator. You could graph the square root of y minus 1 plus 7, and then, or you do x, but y equals the square root of x minus 1 plus 7, and then y equals 13, and find where they intersect. They should intersect at 37. Or if you moved everything to one side and then graphed and found the zeros. So there are different ways to verify, but you always should verify. Because even more so than just with regular equations, sometimes you get answers here that seem to work. You've done everything right, but they don't actually work once you verify. Here's the next example. We're going to go through the same steps as we did before. So the first one was to isolate one of the radicals. Well, here the radical is the only thing on the right side of the equation, so it's already isolated. So we can go right to step 2, which is square both sides. So I'll go squared and squared, and I get m squared equals 2 minus m. What type of equation did I get this time after I squared? A weird one? It's not that weird, because we did a whole unit on it. A quadratic, right. That's the quadratic equation. There aren't any radicals left, so again, I don't have to go back and do more squaring. I'm done with that. What do I have to do to solve a quadratic? Move everything to one side. So I'll change. I'm going to add m to both sides and subtract 2 to put it in a form that I can work with. And for quadratic, that means everything's on one side of the equation and just 0 on the other. And it's in this order: the squared term, then the linear term, then the constant term. And I have some options of how I want to solve that. Yes?
How do you get
So I think I'm going to try to factor this one. If it's quadratic, I could factor, or I could use the quadratic formula. I'm going to try to factor this, because it looks like it'll be easy to factor. How's that look? I think that's factored right. So then we can solve, and we can say m equals -2 and m equals 1. So that's the main work of it, but then we have to consider, what were the restrictions here on the variable? Well, this one's m because it has m's in it, but what is it? M is greater than 2. How do you do that? You're going to look at what's inside the square root sign. Here's the thing with restrictions. We have a 2 minus m inside the square root sign. 2 minus m has to be greater than what value?
0.
Has to be greater than 0. So now I'm just not sure that this m is greater than 2 is correct. So let's go back and check. I'm just going to solve this little inequality. So can I add m to both sides? And I'll get 2 is greater than m, which is not the same as this, is it? No, what should it be? M is less than 2. So the restriction is m is less than 2. Do both of our answers satisfy that? M is less than 2? Yeah, so they're probably both good, but I would still do a quick check. I'm going to do -2 equals, let's see. I'm going to just put that in a different color actually, so you can see that's the check. -2 equals the square root of 2 minus -2. And then I'm going to do 1 equals the square root of 2 minus 1. That's what you have to do to check, right? So this one becomes -2 equals the square root of 4. -2 equals 2. And this one becomes 1 equals the square root of 1. So 1 equals 1. What does this tell you about these answers? Does -2 equal 2? No. So what that means, -2 does not equal 2. What does that mean about the solutions? There's only one solution. M equals 1 is a solution. This, do you know the name for that? Did we talk about this before? This is an extraneous root. I'm thinking we didn't talk about that before. What that means is it is a solution to a modified form of this equation, but it's not a solution to the original. -2, if we filled it in here, is fine. It is a solution to m squared equals 2 minus m, but it's not a solution to the original. So it's not that we made a mistake. Like usually when you fill it in to verify and it's wrong, it means we made a mistake. We didn't make a mistake. It's just that in changing from a radical equation to a quadratic equation, we kind of lost the properties of the radical in there. And so we do end up sometimes with these solutions that we did everything right, we get this answer, but it's what we call extraneous. It's not actually a solution to the original equation, but it is a solution to the modified equation. Here's the last one. It's a little bit more complicated, but I'm sure we can still do it. The square root of 2x minus 5 equals 2 root 2x plus 1. This radical is already isolated, root 2x plus 5. Then we need to square both sides. But this is where we have to be really careful. Squaring both sides means squaring this and squaring this. It's not squaring every individual term. It's squaring the polynomial on that side, on both sides. So the left side's easy. Squaring the square root of 2x plus 5 just gives us 2x plus 5. But this other one, it's about to get messy, isn't it?
Yeah.
Yeah. Because squaring 2 root 2x plus 1 means 2 root 2x plus 1 multiplied by 2 root 2x plus 1. And we get 2x plus 5 equals. I need to use the distributive property, so I'm going to go 2 root 2x times 2 root 2x, which is 4. Can I just say 4 times 2x? Is that okay?
Yeah.
Yeah. And then I'll do 2 root 2x times 1, which is 2 root 2x. And then 1 times 2 root 2x, so that's 2 root 2x. And 1 times 1 is 1. So now if you remember what the third step was, it was to repeat steps 1 and 2. So I need to isolate a radical, and then I'm going to need to square again because I still have radicals here. But I'm going to completely simplify that and get the radical by itself. I'll leave this as is for now, 2x plus 5. That's 8x plus 4 root 2x plus 1. So I just multiplied the 4 times 2x to get 8x, and I combined those like terms, 2 root 2x plus 2 root 2x to give 4 root 2x. And then I will subtract 8x and subtract 1 from both sides. Subtract 8x, subtract 1, and that gives me negative 6x plus 4 equals 4 root 2x. You guys have a job here making sure I don't make any mistakes. We're now back to step 2 because we've isolated this leftover radical. We're back to step 2, which is square both sides. So we're going to square all of this and square all of this. So that means negative 6x plus 4 times negative 6x plus 4. And when I square this, 16 times 2x. That's not so bad. You don't necessarily have to write out this row. If you can do this in one step, that without writing it out, that's fine. But just to see what's happening, now I'm going to multiply -6 times -6, or sorry, -6x times -6x, and that's equal to 36x squared. Then I'll do -6 times 4, -24, and x, -6x, right? And then I'll do 4 times -6x, -24x, and 4 times 4 is 16. And then on the other side, 16 times 2, 32x. Now the good news is, this is a quadratic, and you know already how to deal with a quadratic. It took a while to get us there, though. This is a big question. So now I will combine all terms and get everything on one side so that we can solve that quadratic. So that's 36x squared minus 80x. That's the -24x, the -24x, and I subtracted 32x. And then plus 16 equals 0.
Is that 24x or plus? Negative.
Remove a common factor of 4. I'll have 9x squared. 80 divided by 4 is 20x, and then 16 divided by 4 is 4. So now it's probably easier to factor. This still isn't the easiest thing to factor, but we can probably do it with a little bit of thinking through. Decomposition is probably the way to go for factoring. We end up with the 4 is actually still there, and then x minus 2 and 9x minus 2. Are we done?
No,
Not yet, right?
of course not. Because that'd be easy.
What does x equal? Two? 2 and 2 over 9 are the values for x. If we consider what the non-permissible values are, x has to be greater than 0, which they both are, and x has to be greater than
1.
5 over 2 from here, right? For the restrictions, 2x plus 5 has to be greater than 0. Oh, that's why. X has to be greater than -5 over 2. That works for both of them. X also has to be greater than 0.
So dumb.
We still need to verify, and I'm just going to do the verifying on my calculator. When I do that verifying on my calculator, when I check 2, it comes out to 3 equals 5, which tells me that that is not a solution. But when I do 2 over 9, I get 2.3 repeating equals 2.3 repeating. So that is a solution. So we had an extraneous root again. X equals 2 was extraneous.
I love it when you say that.
But x equals 2 over 9 is the answer.